Here we will see Mutex class in thread synchronization. A mutex is a synchronized locking mechanism which is used to synchronize multiple requests of accessing a single resource. When two or more threads need to access a shared resource at the same time, the system needs a synchronization mechanism to ensure that only one thread at a time use the resource. One resource can be associated with the mutex and that resource can only release the mutex. It enforces the prevention of resources when there are many requesting threads of execution and ensures that a single thread must acquire the resource. Now we will see why we use mutex instead of lock and monitor. Mutex help us to ensure that our code is thread safe. That is, when we run our code in a multi-threaded environment, then we don't end up with the inconsistent result. The lock and monitors ensures thread safety for the threads that are in process, that is, the threads that are generated by the application itself. But if the threads are coming from out process, that is from the external application, then locks and monitors have no control over them. Whereas mutex ensures thread safety for the threads that are out process, that is the threads that are generated by the external applications. Next we will see what is mutex class in C#. Mutex works like a lock that is acquired an exclusive lock on a shared resource from the concurrent access, but it works across multiple processes. As we know, exclusive locking is basically used to ensure that any given point in time, only one thread can enter into the critical section. Mutex is a synchronization mechanism that grants exclusive access to the shared resource to only one external thread. If a thread acquires a mutex, the second thread that wants to acquire that mutex is suspended until the first thread releases the mutex. There are two types of mutex: local mutex, which are known as unnamed, and named system mutex. A local mutex exists only within your process. It can be used by any thread in your process that has a reference to the mutex object that represents the mutex. Each unnamed mutex object represents a separate local mutex. And named system mutex are visible throughout the operating system and can be used to synchronize the activities of the process. You can create a mutex object that represents a named system mutex by using a constructor that accepts a name. The operating system object can be created at the same time, or it can exit before the creation of the mutex object. You can create multiple mutex objects that represent the same named system mutex. Constructors of mutex class are mutex, which initialize a new instance of the mutex class with default properties. Mutex with parameter initially owned initializes a new instance of the mutex class with a boolean value that indicates whether the calling thread should have initial ownership of the mutex. Mutex with parameter initially owned and name initializes a new instance of the system.threading mutex class with a boolean value that indicates whether the calling thread should have initial ownership of the mutex and a string that is name of the mutex. Then mutex with parameters initially owned, name and created new initializes a new instance of the system.threading.mutex class with a boolean value that indicates whether the calling thread should have initial ownership of the mutex, a string that is name of the mutex and a boolean value that when the method returns indicates whether the calling thread was granted initial ownership of the mutex. And mutex with parameters initially owned, name, created new and mutex security initializes a new instance of the system.threading mutex class with a boolean value that indicates whether the calling thread should have initial ownership of the mutex, a string that is the name of the mutex and a boolean variable which indicates when the method returns whether the calling thread was granted initial ownership of the mutex, and the access control security to be applied to the named mutex. Different methods of mutex class are close, which releases all the resources held by the current wait handle. Dispose, which releases all the resources used by the current instance of the wait handle class. Dispose with boolean parameter is used when overridden in a derived class releases the unnamed resource used by the wait handle and optionally releases the managed resources. Equals object determines whether the specified object is equal to the current object. Get type is used to get the type of the current instance. Member-wise clone creates a shallow copy of the current object. Open existing method opens a specified name mutex if it already exists. Release mutex releases the mutex once. ToString method returns a string that represents the current object. Try open existing method opens a specified name mutex if it already exists and returns a value that indicates whether the operation succeeded. Wait1 method blocks the current thread until the current wait handle receives a signal. Wait1 method with integer parameter blocks the current thread until the current wait handle receives a signal using a 32-bit signed integer to specify the time interval in milliseconds. Wait1 method with integer parameter and boolean parameter blocks the current thread until the current wait handle receives a signal using a 32-bit signed integer to specify the time interval and specifying whether to exit the synchronization domain before the wait. Wait1 with timespan blocks the current thread until the current instance receives a signal using a timespan to specify the time interval. And wait1 with parameters timespan and boolean blocks the current thread until the current instance receives a signal using a timespan to specify the time interval and specifying whether to exit the synchronization domain before the wait.